Okay, today in class we learned to calculate pH. Before we did pH, we learned a very simple formula called the KW formula, and it teaches us how to calculate hydronium and hydroxide if we just have those two. First, we talked a little bit about just water. Sometimes water will bump into another water molecule and it will steal hydrogen from that other water molecule. It doesn't happen often, but occasionally. And when you get that, you get hydronium and you get hydroxide. So water has equal amounts of both of those, which is why water has a pH of 7. They're the same value. So if you get more hydronium, you're going to get an acid. If you get more hydroxide, you're going to get a base, and you would not have pure water. So I'll continue to click through this, and I've uploaded the PowerPoint as well. So Kw is going to be a constant, and the constant is going to always be 1 times 10 to the negative 14th. 1 times 10 to the negative 14th is known as the constant for water, and it will equal the hydronium times the hydroxide. So you can use this constant and those two things to solve for the other. If it's pure water, they're going to have equal concentration, so your hydronium and your hydroxide will both be 1 times 10 to the negative 7th. Because if I multiply these numbers together, you multiply the front numbers, 1 times 1 is 1, and you add the exponents. A negative 7 plus a negative 7 does equal a negative 14. So pure water is equal. And so then we worked one simple problem. And it says, what is the hydronium concentration of a 0.035 molar solution of hydroxide? So we know hydroxide, and we're looking for hydronium. So we'll start out with the Kw, and we'll set it equal. We don't know hydronium, so that's going to be our X, and it's going to be multiplied by our hydroxide. Hydronium times hydroxide equals the Kw. So to find X, we simply divide both sides by the 0.305, and you can simply find the other. So very, very simple to find one if you have the other. So we should have gotten 2.86 times 10 to the negative 13th power. So not very much at all. In fact, that's to the negative 13th. There's hardly any hydronium, but there's more hydroxide, so this is actually a base. And then we learned how to use the pH and the pH formulas. pHs actually stand for power of hydrogen or power of hydronium, whether you think of it as H plus or H3O plus, depending on Bronsted, Lowry, or the Arrhenius definition. But the scale is based on log scale, which is what a lot of the science scales are based on. They're based on the logs. And so on the scale, we usually think of it from going from 0 to 14, with 7 being neutral. Whoa, I don't know what happened there. With 7 being neutral. Okay, and the more you go this way, you get more basic. So a 14 is a lot more basic than a 12. The more you go this way, you get more acidic. And it doesn't seem like there's much difference if you go from a 7 to a 4, but every time you move from one number, it's 10 times more. Go that way acidic, go that way more basic. So that's 10 times. That's 100 times. That is 1,000 times more acidic. Go one more, and that's 10,000 times more acidic. So that's what logs are, is moving by the power of 10 between the numbers. So we're just going to use the log, and it will just be simply button on our calculator. And so then we looked at 3 formulas, and so you'll need to write these down to be able to know which ones I'm using when I go to the next slide. So these are our 3 formulas. So if you need to hit pause, or if you have the note sheet, you should be looking at it. So these are the 3 formulas. We're really not going to use this one right yet. We'll use that one in a couple of days. We're going to be using this one. They're technically the same thing. pH stands for the power of hydronium, so we are going to be taking the negative log of hydronium. pOH stands for the power of hydroxide, so we'll be taking the negative log of hydroxide. And there are actually 2 scales. We really talk about the pH scale, but there's something called the pOH scale, and they always add up and equal 14. So we're going to be using, for these next 2 examples, these 3 formulas. Okay, we'll begin. So it says you have a 0.03, I'm sorry, you have 2.51 times 10 to the negative 13th molar of your hydronium. So if you look in those formulas, there's only one formula that has hydronium. First off, I want to say that brackets means concentration, so that's where the molarity is going to be going. So these guys will be measured in molarity. These are a scale, so they don't have a unit. So there's no unit on these guys. Okay, so these will have a unit, these two no unit. All right. So there's only one formula that has that, and that is the pH. Whoa, I'm having all kinds of problems today. pH equals the negative log of 2.51 times 10 to the negative 13th power. So we're going to type that in just like that. You're going to hit negative. You're going to hit the LOG button on the calculator. And then you're going to put in 2.51 times 10 to the negative 13. So you're not going to do anything with the unit. As far as pHs are concerned, normally I like you to go out 2 decimals unless they just kind of come out to be pretty even. This one comes out pretty even to be 12.6, so you don't have to put 12.60. For these guys, I would like 3 sig digs. For these, I'd like 2 decimals. So that is the pH. pH is a negative log of that, so 12.6. All right, well, I don't seem like I have much other information here other than the fact this is a pH of 12.6, so therefore this is a base. Now what I said a while ago is these two add together will always equal 14. So if I know one, I could always find the other by subtracting. So if I go 14 minus 12.6, you will find that the other scale is 1.4. And I told them in class that you don't have to show the subtraction. I would like this other stuff showed, but you don't have to show the subtraction. So now that's a very easy thing to get. So once we know that, I'll continue working here. The only thing I've left to solve for is hydroxide. So if I look in my formulas, and hopefully you wrote them down, the only one that has hydroxide in it, other than the two added together, is that the pOH equals the negative log of the hydroxide. So if you see that, well, I know the pOH, it's right there. So 1.4 now equals the negative log of the thing that I don't know. So there's what I'm looking for. There's x. All right, so now we need to get x by itself. Logs are a little special. So to get x by itself, we're going to first take care of the negative. And how do you take care of the negative? Well, my teacher told me just to change the sign, but most of you have learned divide by -1, multiply by -1, whatever. So there's going to take care of the negative. That's going to get rid of that. And what does that now make? We got a negative 1.4 equals log of x. Now, to get rid of log, because we're trying to get x, that's our goal, is to get x. So I'm switching to red when we're getting rid of something. The way we get rid of logs is you go second log. Okay, so you're going to hit the second button and the LOG button. What it makes is this on your calculator. It makes a little 10 house top. So what you're going to tell it to take 10 to the power of is this right here. So you're going to go second log negative 1.4, or you can think of it, this is what's looking in your calculator there. That's how you get x. So then we're going to round to 3 significant digits because we are looking for a concentration, and I would like these in 3 significant digits. So this comes out to be 0.0398 because the beginning zeros are not significant, and then m because it needs a unit. And that's about as difficult as I get, but we'll go ahead and work example number 2 as well. Let me take another picture. All right, so number 2 is giving us a pH of 5.86, so therefore it's an acid because that's the pH scale we want to look at. We could find the pOH because these two things should add and equal 14, so therefore I can take 14 minus 5.86, and I will find that this is 8.14. Okay, so now that we've got that, I'm going to look at my formulas and see what I can do to find hydronium. And a hydronium, it has to do with pH. These two go together. And then these two go together. So pH, I'm going to write the formula so you can see it. pH equals the negative log of hydronium. So I know the pH this time, so it's 5.86 equals the negative log. I don't know that, so that's x. I got to get the negative to the other side, so I've got to divide. You don't have to show me all your algebra. I'm doing it just for you know what I'm doing. So I'm dividing by -1 to get rid of the -1. So put that over there. Now to get rid of the log, you have to hit second log. So now it's going to make times 10 to the, and you would put 5.86, negative 5.86 in there. Don't forget the negative, you'll get a really large number. Okay, you should not get really large numbers, you should get really small numbers. So there should be either decimals or times 10 to a negative power. So you're going to get 1.38 times 10 to the -6 molarity. And the reason I'm putting it right there is because pH gives me that. Alright, I've got one more spot. Honestly, now that you've got hydronium, you could use the KW formula to find hydroxide. So that is one method to do it, but we're working with just the 3 formulas right now. So I'm fine if you use KW formula. But, like I say, these two go together, and it keeps jumping up there for some reason. All right, so I'm going to say the pOH equals the negative log of hydroxide. All right, so pOH is 8.14, negative log, I don't know that guy, so he's x. Send that negative over to the other side. Now you've got log of x. Now to get log by itself, you go second, or get x by itself, second log to get rid of the log, and you get 10, and it's as simple as that. And so we should be getting 7.24 times 10 to the -9 molarity. And that is all there was for that lesson. We stopped and we didn't do the back page, so when we get to the worksheet, we only are doing numbers 1 through 12, and I will try to upload those answers for 1 through 12 as well. So hopefully the video has helped.